class. Welcome to our final video. We're going to be talking about our last kind of new topic. We're going to go through the engineering design process and specifically about creating prototypes. So we'll go through these a few times, but you're going to identify the problem. So what's the challenge? What are the limits? How can you solve it? Then you'll explore, find out what others have done, gather materials, play with them, see what you can do differently to make it better, design, think up lots of ideas, pick one, make a plan, and make a drawing or model of it, then create it. And here's where you're making your actual prototype. You'll use your plan to build your idea, then test your idea, try it out, see if you can finally make it better and maybe redo it, modify, try again. So we're going to dive into that even more, into the details. So we kind of talked about these 7 steps: define the problem, conduct research, brainstorm and conceptualize, create a prototype, select and finalize the best prototype, and then analyze and continue to improve. Okay. Wrong thing. So in creating a prototype, first you need to identify the user needs or identify the problem. If you're the user and you're just trying to create a new product or an idea or a business or whatever it might be, you want to research, see what's out there. You want to know your competition, see if it's already been done before, and look at ways that you can improve. So here's just a few things that you can do to research, and then you'll define the problem. Make sure you understand what the true need is. What's the purpose of that? Is like my husband does a lot of this as a material scientist, and they work with these really big companies. And sometimes they just want to see if you can do it. They've done it to them. I've seen from places like GM and stuff. They'll be like, I'm going to give you these parameters that nobody's ever attained before, and we'll just see if you can do it. They don't necessarily tell them that. They'll be like, we need this, this, and this. And then they do it, and they make a high-strength steel that's cold formable, and so it's stronger, so you can make it thinner and lighter, so they can make the vehicles lighter and more fuel efficient. And they did it, and they're like, oh, we didn't think you could do that. Well, now let's bump it up a notch and see if you could beat that. And so it can be kind of a frustrating process. So if you can really nail down like what it is they really want, so you're not having to go through this process so many times, that is a good thing, because it takes a lot of time and effort, especially when you're creating new materials at like the molecular level, to do some of these things. I don't expect you guys to do them, but it is a career out there, and there's fields that are just prototyping and companies that just do prototyping. And then consider the constraints, like what's your cost? What's their cost goal for their cost? What material should it be made of? How soon do they need it? And that will all factor into your prototype and what is available. I know in his current company that he's working with is another kind of green company. They're doing bio-based plastics, and they're working with some bigger companies. They are a small, kind of more research-based company, but they do a bio-based plastic made with starches. And so when you blend that with regular plastic, it can actually biodegrade both the regular and the starch-based plastic. But they're like, we need it to be the same price or cheaper. And you're like, well, it's environmentally friendly. It's going to cost a little more to make it. We can't make it quite as cheap as the cheap plastic that has been being made for a while. And so there's those give and takes. And so they keep trying to do things to make it cheaper and working with other bio-based plastics to make their things cheaper. And so we're always testing out everybody else's different straws. We're always doing experiments and comparing and doing research. Like, ooh, here's a bio-based straw. They say it's biodegradable. Let's test it out. All this competition. And some of them, they're actually now working together to see if they can use both of the materials to make it more affordable so that we can have better products that are better for our planet. So I think it's cool. I like to learn about it. Not everybody does, but something to consider. There's a lot that goes into things behind the scenes, and cost is a huge one. They were looking at like all the waste in the medical fields because everything comes wrapped in plastic and it's not biodegradable. It just becomes trash and turns into microplastics and ends up in our water and in our food and everything. And so they're like, if we could just get them to use bio-based plastic, it would be so much better for the planet in the long run. But they're like, no, we can't spend even a penny more, like not a penny, because budgets are so tight. So there's definitely uphill battles too. And even working with the government to create standards, because at this point there isn't a standard. And so people will say like, oh, it's biodegradable. Well, it's maybe lab biodegradable. So it has only biodegrades in certain conditions. It has to be a certain temperature, certain humidity, certain biomass, and all of these things. So much to look into. Sorry, I'm geeking out on you guys. So yeah, things to look into, making sure that when you're constructing a prototype and trying to turn things into a tangible product, you need to look at things such as materials, the tools that you'll need, and different methods, and then finally testing. But I have a quick video so you can kind of see some of the rapid prototyping options.
In general, rapid prototyping includes technologies and techniques that let engineers and designers create a three-dimensional scale model of their design, usually to test for form, fit, or function. The technologies include 3D printing, additive manufacturing systems, CNC machines, and injection molding systems. The selection of which approach an engineer uses depends on design needs. 3D printing began as a way to prototype quickly. The other choices, CNC machining and injection molding, have a long history in both the prototyping models and production of end-use parts. However, they both have several drawbacks. It is often expensive to create the tooling needed to make the prototype, and it can take weeks to obtain the prototype part. 3D printing, on the other hand, was developed to address these drawbacks. Depending on the prototype need, you can spend as little as $3,000 for a 3D printer, and you can build parts in hours or days, depending on the complexity of the part. Plus, the cost of that one 3D printer is usually paid back in a couple of months, versus the cost of CNC and injection molding equipment. One drawback with 3D printing, though, is the prototype may not be in the engineer's desired material of choice, which can limit how much testing the engineer can do on the prototype. Materials for 3D printing are improving. In fact, 3D printing is shifting from a pure prototype solution to a volume manufacturing production approach of end-use parts. Even so, both machining and injection molding offer a wider range of materials. When deciding among the methods, one point to consider is the total number of parts to be made with or from the tooling. If you need only a few hundred, 3D printing can be the best choice. If you need thousands, then it is worth the investment of machining or injection molding to develop a long-lasting tool. 3D printing is an excellent choice when you are creating a mold and expect a number of revisions or iterations before developing the final tool. Once the tool is finalized, then machining or injection molding become cost-effective choices. For more videos like
So hopefully you found that interesting and learning a little bit more. But our next discussion board is on 3D printing, and it's really interesting to see kind of how far it's come. Sorry, it's wanting to go to something else instead of my next slide. So this is kind of our final thing. Once you have made that prototype, you need to test it and see how it works, see if it meets your goals you set. Maybe it exceeds them. Maybe you can cut back costs and do something if it is exceeding them so you can make it more affordable. And just making sure that you take down all of your results and have that proof of concept. So there's a lot of things. A lot of universities do these type of things. They'll hire interns in the university to do these testing and all of these experiments on prototypes. I know that's something that my husband's done with different companies, is outsourced to universities. So maybe you guys will get to do that at a university as an intern. There's definitely jobs there. So there's lots of cool things that you can do, and always learn and improve your product or your idea. And I don't want to keep going on because I could talk forever, but just a review of the engineering design process. First, you'll come up with your question and imagine and try to figure research and stuff, and then you'll do your planning. Then you'll create your prototype. Then you'll experiment and improve it. That was just kind of a cute little thing just to review and help you remember. And then next, we'll talk about 3D printing with rapid prototyping in our discussion board. And most of all, I want you guys to get creative. We need more creative minds and more creative solutions to our problems and multifaceted solutions to our problems. So don't be afraid to get creative, especially in your brainstorming if you're ever in a problem-solving group, because we need those solutions to make our world a better place and solve the big problems these days. So it's been wonderful working with you. Good luck on your review and everything else, but this is kind of the last of our new topics, and hopefully I'll get to work with you again. Bye.